Thank you. Good afternoon, ladies and gentlemen. It's actually weird to not get any visual feedback, but we're still getting used to this virtual mode. I'm Ramandeep Singh. I head the test automation group at Infotech. So I head a lot of test automation deliveries as well as the research and development that goes on into test automation. Uh, Today, I'm going to demonstrate and talk about one implementation for a test development kit that we're doing at Infotech, which speeds up the process of developing automated tests for any application which is built on top of a no-code or low-code application development platform. Hence the name Cogburn, a TDK for rapid test automation. Okay, I'd like to share my screen now. I hope it is visible. Okay, the application development industry of lately is seeing a bombardment of a lot of no-code and low-code application development platforms. SAP and Salesforce have been doing this for many years for basic office automation for things like ERP, SRM, CRM, uh, HR, payroll, invoicing, and all such necessary office productivity automation. But of lately, we are also seeing a lot of emergence of low code and no code application development platforms for other verticals also, like e-commerce, like mobile application development. But when we talk about test automation, we still use the same age-old proven techniques of test automation, which were proven and work very effectively when we test an application which is built from scratch. But for the applications that can be rapidly churned in days using these low code and no code application development platforms, these test automation methodologies are proving a little inefficient. There is this gap of efficiency that we lack in the current test automation methodologies. Cogburn is an attempt, an initiative that we are making in Infotech in order to develop some test development kits or TDKs, which makes it really easy and quick to develop automated tests for an application that is built on top of the low code and no code test automation application development platforms. Today, I'm going to demonstrate one such implementation under Cogburn initiative. Uh, so let's look at the agenda for this presentation. I'm going to talk about, briefly talk about the problem statement, and then talk about the concept and theory that goes behind the implementation of this solution. Then I'm going to show you a live demo of one of the implementation of this solution and walk you through the demo as well. And then finally, I would talk about the benefits and the byproducts that we reap out of this implementation. And then I would talk about where we would like to take this in future in terms of the future implementations and the next steps. Test automation has evolved a lot over the last 10 decades. I mean, we were building those monolithic test scripts where all the test implementation was right in one file to then we moved on to more modular automated test code where We were using things and design patterns like data-driven testing, like page object pattern or page object modeling that was made popular by Selenium. Then techniques like domain-specific languages for test automation for building automated tests in a more domain-centric application test objective specific way. And then now we are doing a lot of test automation using development methodologies like behavior driven development, acceptance test driven development as well. But at the core, the test automation for any UI application has remained the same. You first identify the elements that are there on the UI, give them logical names in your automation code, create functions that represent the actions or assertions that you want to do on these elements, the UI, and then call these functions in your test scripts to build an end-to-end test case and test automation. And this is really expensive. It takes a lot of time to build automated tests for a UI because you have to identify the elements by looking at the UI and then construct these functions and then call these functions in the automated tests in the test scripts. For the applications that were built traditionally in a standard stack without a low code or no code development platform in picture, these development methodologies for test automation were at par with development of the product, and they were really cost effective and not as expensive. But with the emergence of these low code and no code development platforms, I mean, look at Salesforce. Anybody can develop, any Salesforce developer can develop a full fledged customer relationship a workflow in Salesforce in a couple of days with bare minimum coding. But for doing the test automation using this methodology, we're going to take at least a week because we have to identify each of the elements of the various forms that a person has to go through in order to fulfill his CRM workflow in Salesforce and interact with that form, fill in the details, and set up the data and everything. So that takes a lot of time. So there's this huge gap between the efficiency of the existing automation methodologies and the way the industry is heading towards low code and no code development platforms. So how do we bridge this gap? How do we take the next step in test automation away from already existing frameworks and solutions and tools so that we're at par with low code and no code application development platforms? Well, we already had AI and machine learning in picture, and a lot of development was being done around them, and it's still being done. For that matter, at Infotech also, we did a lot of research around using ML for UI test automation. But even today, either these AI models that we build for test automation are really pricey and expensive to maintain because it takes a lot of resource to build them and a lot of time to build the right model, or they're not uh, correct or successful enough that they can be implemented for a full-blown test automation. The error rate is still too high. So it certainly is promising, but still does not give us uh, enough leverage to start using them for full-blown test automation. So what are our options? Let me present you one possible option. We have a theory. Now, these low code and no code test application development platforms, all of these platforms expose a lot of APIs, feature sets, function libraries for the developers, which the developers then consume in order to either configure and implement their final application or extend that for integrations further with other kinds of applications and third party services. What if we can, for test automation purpose, exploit these existing exposed APIs and function libraries that are within these application development platforms and convert them in such a way that they can be used directly for test automation as well and get that leverage that the developers are getting for development for test automation as well. I'll give you an example. In Salesforce, There are so many open APIs that are available that can be exploited for test automation. There is a series of metadata API that Salesforce provides, with which you can get information about any object entity that has to be created in Salesforce, to a level that you can get information about what what kind of objects or elements would be there when you want to create this object in the UI. What would, as in whether it would be an input box, whether it would be a drop down list, whether it would be a multi select list, whether it would be a radio button. So all this information is directly available through metadata API. And then Salesforce also exposes its whole RESTful and SOAP CRUD based API for anybody to create the methods, the objects directly through API, which can again then be used in automation as well. So if we, let's say, build a library which consumes this metadata API, such that at runtime, all I need to do is call a function from this library, which takes in the data that I want to enter into a form in Salesforce, and at runtime fires the metadata API query, gets the information about the fields that are rendered on the screen, creates locator dynamically at runtime while the test is being running, and then fills the form and submits the form right there. I don't need to, at the test automation level, create the locator and the page objects and all those dependent things for any test case anymore. All I have to do in my test case is to call the function from the TDK, which then internally does all these things automatically for me. So that's the advantage and leverage that we get from exploiting and using these APIs. And on top of that, because now we have access to the APIs, the internal structure of these low code and no code application platforms, we can actually use them for doing testing of edge cases by mocking and service virtualization, as well as doing data validation, not from the UI, but at the backend directly for any test validation that we have to do. So now imagine a library which gives me a bunch of functions which I can call to either fill a form with certain amount of data, certain kind of data, test data, or validate when an entity is created, that what are the attributes of the entity once it is created, or transform that entity by performing an action on top of it in Salesforce. That's exactly what we did. We implemented this theory into an actual test development kit for Salesforce. And let me show you a demo of this implementation. So I'm going to switch to my desktop. Okay. So let me run the test, and then as I'm running the test, let me talk about what is happening in the test. So it's a basic Selenium test. The test triggers and it launches a browser. Now the test would start my Salesforce organization in the browser, log in with my account, my Salesforce user account, and then it would try to create a lead by filling in the lead creation form. That is exactly what it is doing right now. It is trying to create a lead by filling in the form details in the lead, and then it will validate that the lead was created on the UI by opening the lead from the list of leads. Then it would convert the lead by clicking the convert option in the lead and entering the data necessary for lead creation, lead conversion. Once the lead is converted, the Salesforce is set up in this organization is set up in such a way that if a lead is converted with valid data, it would result in creation of an opportunity and an account that matches the information in the lead, a contact and an account, a business account for that lead. So once the lead is converted, we are going into the UI and validating whether the opportunity was created with the right data or not, and whether the contact and the account information was created as well as or not. Let me open the test script. Again, this is the Ruby implementation of this TDK. We have the TDK implemented in Java and JS as well. but for the purpose of demonstration, I'm showing the Ruby implementation. Now, for the most part, the beginning lines of this file are the standard test automation lines that you would see in any test script. So this is a standard RSpec-based test script. If you look at line number 35, the one that I've just highlighted. So this is the line where we're actually invoking a function of TDK directly rather than performing a UI operation using standard Selenium. So what is happening is we are actually reading the test data for lead creation from a YAML file from an external source, and then passing the test data to a create function in TDK, and we're asking them to create a lead. TDK now knows that I want to create a lead. It would go in, fire the metadata API, get the information about the metadata for a lead, create the constructors, the locators for all the elements at runtime, open the lead form, fill in the information that I have given as part of my test data, and it would pass on the information, pass on the control back to my test script, and then I can then call the remaining test steps to make sure my whole test assertion is done. Had I not used the TDK, I would have created page objects to represent the lead creation form and all of its elements in there, and then actions to fill in the details and click on the save button as well. So you would actually see a bunch of code lines right here, either directly here of Selenium or called as part of the page objects, which is automatically done for me if I'm using this TDK. Okay. So what are the benefits that we are getting out of this TDK implementation? Now, this is just one possible implementation of Salesforce. Again, I've just shown you a very small part of it. There are more things that we're doing from this whole implementation. But what are the benefits that we are reaping out of it? First and foremost, this implementation of TDK is really minimalistic. It is actually suckless that it gives me enough leverage that I can design and decide what form I want to express my automated tests into. In my example, I have shown you an RSpec test in Ruby where I was calling the TDK. The TDK did not dominate or tell me that this is the ID or this is the kind of way in which you define your test case. I'm still free to creatively decide what the test case structure would be, what toolware I'm going to use to build the test. It could be RSpec, it could be Cucumber. In Java, it could be JUnit TestNG or JBehave Cucumber. It could be anything that I decide that I decide at the test level and not driven by the requirements of this TDK at all. It's just a supplemental library which I'm consuming inside my test. Hence, it is very minimalistic in nature, which gives me these domain functions that I can call in my test and do the test automation. For most part, for the Salesforce TDK, it is locator free. That means I don't have to create page objects and give logical names to the locators and make them available for my automated test. For most part, that means for all the standard entities and objects available in Salesforce, as well as the custom objects available in the Salesforce, we can create the locators at runtime using the TDK by using the metadata API internally. We don't have to do it. But for any custom things that are being done on top of Salesforce by building a custom UI, you still, because this is a minimalistic library, you still have the option of building your own page objects for any of those custom things where you specifically want to test out those UI customizations. You still have the option of building the the customizations, the page objects yourself, and then building the library and automation code yourself. For instance, in this case, I've built this convert function. Let me go into the function. This is standard page object function where I'm identifying the elements and then performing an action using Selenium actions rather than the TDK. It's although I can do it with TDK also, but in order to demonstrate the capability of merging two different codes together, I'm just showing this this aside. Okay. So you have the option. For most part, it is locator free, but for any customization that is happening on top of the UI, any third party integration that is happening, you can still do it by building the standard page objects for those custom things. So it's absolutely extendable in that sense. It's fluid, and uh, it automatically corrects itself whenever there are changes in the configuration or in the version or details of Salesforce directly, because the TDK is extracting and reaping all the APIs from the Salesforce directly. If that changes, the development, the functionality changes, so does the test automatically change for you for in most of the cases. And in cases where it doesn't change, you don't have to go in and do a lot of coding in there. You just have to go in and modify the test data that is associated with the domain functions for you that you're calling in within your test. And since this is minimalistic API, it is supplement to your test framework. You can build a framework and a wrapper around it. This itself is not a tool. It is extendable the way you want. You can use your own creativity for reporting structure, for CI/CD structure, for building a BDD and ATDD around this. Now then, there is one byproduct that I'd like to highlight of this solution as well. If you give any UI-based application for test automation to any test automation developer, they would start approaching it for unit tests of the UI first. They would look at the forms and try to build tests for each of the elements, the presence of the elements, the validation of the elements first, and then they would build end-to-end tests, which test the business rules and the workflow logic that is created by developers behind this UI. But where but in case of TDK, we are giving them a way to perceive and change the perspective of defining the test case. Since they have domain functions available, they can straight away start using those domain functions to build the automated test and remain more in context with testing the rules and configuration that the developers are doing by using these development platforms to build the application. So the test objective and the automated test in this case reap higher benefits and higher returns because we are testing the things that the developers are doing rather than testing the platform and the UI directly. Rather than unit testing the UI, we're actually testing the business rules and the business logic and the configuration that is being done in order to generate and implement the whole end-to-end workflow for an application. So it actually helps in test developers start thinking from an domain perspective and start implementing the tests with high efficiency and high effectiveness. Now, we want to take this further. So I've shown you one implementation for Salesforce. We're also doing a similar implementation for Hybris, where we're going to use most of Hybris' API and UI templates for building a similar Selenium-based domain-specific TDK, which gives you the functions for doing automation for Hybris-based e-commerce application. But that's forthcoming. We're working on this. Then for Demandware, we worked in the past on a bunch of e-commerce applications that were built on top of Demandware, where we were using and consuming the API of the Demandware directly to do some data validation on top of the automated tests that were built using Selenium. For instance, like we wanted to at runtime find out from the catalog of the whole market one product which has only one quantity available, so that I can test the edge case where if I try to add quantity 2 for this product into the cart, it should fail. Now we were calling the Demandware API to query and find one such product from the catalog, and then from the Selenium UI, from the Selenium automated, we were calling that particular product ID to execute this particular test. Now that was a primitive version of the TDK. We want to now enhance that older version of TDK to a full-blown domain-specific TDK for Demandware for any application that is built on top of Demandware e-commerce. So that similar approach can be implemented and it can become a rapid test automation for Demandware as well. With this, I'm done and open for any questions from the audience. I think I'll have to go back to, okay. Okay, I don't think there were any questions. Okay. All right. Thank you for all of you who attended this session. If you have any queries, you can contact me. Have a pleasant day. Thank you.